Hello, this is Lesson 3 from Unit 1, your Integrated 3 channel. And today we just want to remind you to be all you can be. You're not yet the person you will become. Okay, so today we're tracking the tortoise. This is not new material or new ideas. This is Solidify. We're going to look at an exponential function and its inverse. So here's the story. You may remember a previous lesson about the famous race between the tortoise and the hare. In the children's story of the tortoise and the hare mocks the tortoise for being slow. The tortoise replies, "Slow and steady wins the race." The hare says, "We'll just see about that," and challenges the tortoise to a race. So that's the end of the first paragraph. Today we'll consider the journey of the tortoise in the race. Because the hare is so confident that he can beat the tortoise, he gives the tortoise a 1 meter head start. Let's mark that down. Won't the hare be surprised when he finds that Shelley is a wonder tortoise with supersonic exponential speed? Reminds me of a movie. The distance from the starting line of the tortoise, including the head start, is given by this function. The tortoise family decides to watch the race from the sidelines so they can see their darling tortoise sister, Shelley, prove the value of persistence. Well, I'm sure that this would work if it was a darling tortoise brother as well. So let's see. How far away from the starting line must the family be so they are located in the right place for Shelley to run by 5 seconds after the beginning of the race? Okay, so that's a substitution. That's really saying, what's d of 5? And that would be 2 to the 5th, or 32 meters. And after 10 seconds, that would be d of 10, and that would be 2 to the 10th, 1,024 meters. Describe the graph of d of t. Shelley's distance at time t. What are the important features of d of t? Well, it's exponential. Excuse me, you know that. The y-intercept is 0, 1 because d of 0 equals 2 to the 0, and that's 1. So 0, 1 is definitely on this graph as the y-intercept. No x-intercept. Okay, and continuous? Yeah. And what else? Domain? Okay, let's see. So this is the one that goes from 0 to infinity. And the range, let's see. According to the story, the range is not necessarily, well, look at it's Shelley's distance. It's not necessarily from negative infinity. Shelley got a head start. So Shelley actually started at 1. So that would be 1 to whatever, infinity. Okay, number 3. If the tortoise family plans to watch the race at 64 meters away from Shelley's starting point, How long will they have to wait to see Shelley run past? Okay, so that would be replace the d of t with 64 and then calculate this. Well, at this point, you're going to have to guess the answer. I take that back. That would be t, not x. You're going to have to guess the answer. So powers of 2, that's 2 to the 6th. So it's 6. How long must they wait to see Shelley run by if they stand 1,024 meters away from her starting point? Okay, so remember, we did this a second ago. This is up here, right there. So it would be 10 seconds because 2 to the 10th is 1,024. So t equals 10. Next page, draw a graph that shows how long the tortoise family will wait to see Shelley run by at a given location from her starting point. Okay, so let's go by, let's see, on the x-axis, how about, see if we get it out to 30, that would be great. Maybe 10, 20, 30, yeah, maybe like this. And on the y, let's see, so this table is how long, that's going to be the y-axis, and how far is going to be the x. So looks like they reversed the original function. This is going to be the inverse because it says at a given location from her starting point. So that means that's the independent variable. You give me the location, I'll give you the time. So let's see, going up, let's at least get to 5. So how about every 2 squares? There's 1, 2, 3, 4, and 5. And excuse me, as far as the graph goes, we can use our previous values from before. Okay, so here's the head start right here. And from some of these other numbers that we figured out here, at 5 on the y, we should be at 32 on the x. So let's see, each of these squares must be worth 2.5. So it's right about here. Let's see, anything else? How about 4 would have been 16. So it's an x value of 16, go to 4. And then 3 would have been 8. So 7.5. So right about there. And 2 would have been 4. 2 seconds, 4 meters. That is meters. This is distance. Meters, and these are going up. These are seconds. So right about, let's see, That would be right about, you know what, I think I have the first point off a little bit, because that's not 1. Oops, there goes my axis. 1 would be a lot closer to 0, 0. So right about there. So it comes up and then goes over like this. And would keep on going that way, actually. How long does the family wait to see Shelley run by if they stand 220 meters from her starting point? Okay, 220 and 2 to the t. Okay, so knowing your powers of 2 is going to be helpful here. 2 to the 7th is going to be, let's see, 2 to the 6th, 64, 2 to the 7th, 128. 2 to the 8th would be 256. Since 220 is in between those values, right? So then the time would have to be in between 7 and 8. Seconds. What is the relationship between d of t and the graph you have just drawn? How did you use d of t to draw the graph in number 5? Well, that's no big surprise. They're inverses. Consider the function f of x equals 2 to the x. What are the domain and range of f of x? Okay, so now the story's kind of over, and we're exploring this idea a little bit. The domain and range of f of x, the domain is going to be from 0 to infinity. The range is going to be from negative infinity to infinity. Now you can really tell this on the grid. I'm going to just go for 0, 0 in the middle, just to make it easy on myself. Whoops, I have those reversed. Those are reversed. I was thinking of the inverse already. Okay, so this would be from negative infinity to infinity, and this would go from 0 to infinity. So look, if I just do 2 to the x, every square is worth 1. So there's 0, 1. 1 is 2. 2 is 4. It's doubling. Okay, and then right like this. Okay, and this is an asymptote along the x-axis. The inverse is going to reverse those, right? So this would be for f of x, and this would be for f inverse of x. Domain and range are going to reverse. Domain 0 to infinity. Range negative infinity to infinity. Now, that's going to be a reflection, of course, across the line. So it's going to, if you just take the points and reverse them, 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. And so on and so on. So this thing looks like this. Comes over like this. And of course you have that y equals x line. That's a reflection line, as we've discussed all unit long. Okay, so did that. The domain and range of f inverse. I guess I already did that. And one more question that I skipped over was, is f of x invertible? Yes. It's 1-to-1. It's 1-to-1. Its inverse is 1-to-1. It passes the vertical and the horizontal line test. Number 9. If f of 3 is 8, what is f inverse of 8? Well, it just takes you back to 3. That input right there becomes the output of the inverse at the same output value. If f of 1/2 is 1.414, what is f inverse of 1.414? It is 1/2. How do you know? That's what inverses do. So if f of a equals b, what is f inverse of b? The answer would be a. Will your answer change if f of x is a different function? No, it won't. This is true for all inverses. For all inverse functions. Pretty cool, right? So you learned a lot there. Let's name this inverse. This inverse function right here is called a logarithmic function, a logarithm, or we just abbreviate that as log. In fact, we would write this as, so since it's f inverse, we say log with a base of 2 of x. Because 2 was the base of the exponential, 2 is the base of the logarithm. So some takeaways we can think about here from this lesson. The inverse of an exponential is the logarithm. We got that. Both the exponential and logarithmic functions can have different bases. So we wrote that. And the graph is a reflection over the line y equals x. We got that. So all the stuff that would go here, we actually wrote that above. And then inverse functions, what do they do to each other? So they have, if f of a is b, then f inverse of b is a. Takes you back to where you started. And so let's look at f of x is x squared, and f inverse of x is the square root of x. F of 2 is 2 squared, that's 4. And f inverse of 4 is 2. Of course, we're talking about a domain restriction on this one. Oops, I didn't mean to erase. A domain restriction over here that x has got to be greater than or equal to 0. And then look at your new vocabulary, just the logarithm. That is getting you ready for the next unit. All right, we'll see you later. Have a great day.